Today we're going to talk about dew. What is dew? Dew is where there's water droplets forming from the water vapor in the atmosphere. It's condensing from a gas into a liquid. And the dew point is the temperature at which the water vapor does that. The dew point is the temperature at which the water vapor turns from a gas into a liquid. Now, I want to know, is it the dew point outside? Did it hit the dew point last night? And one of the ways I can test that is I can go out to my lawn and I can take a tissue, there's a Kleenex tissue that you normally use for blowing your nose. That tissue, if I lay that down on the grass and I get little droplets of water, that means that there was dew last night, dew form.
Or it could be the sprinkler.
Yes, and I'm glad you mentioned that because this morning I was going to do that, but I got out there too late and the sprinklers had already gone off. So if I was to put this on my grass now, it would be all wet. But I want you to try it. Find a tissue and go out and test the lawn this morning somewhere to find out if the dew formed last night. In order for dew to form, there needs to be at least two factors in place. The first is the temperature, and the second is the humidity. So I want you to tell me, when was the last time that it became the right point for dew to form in Sacramento? I'm giving you a link to the National Weather Service that's telling us the temperatures and the humidities for the last week, for the last 7 days. And take a look. Take a look at where that meets up. And what you're looking for is where the temperature and the dew point are at the same point. The same temperature meets the same dew point. The black is the dew point and the temperature is the blue line. Now, where those cross is where the dew would form. Did they cross? No, they did not cross. If they didn't cross, it means because it's been really warm. There's been a lot of humidity. There's a lot of moisture in the atmosphere. Warmer air is actually able to hold on to more moisture. But if it doesn't reach upping in temperature, then that moisture will never reach the dew point and it won't condense onto our blades of grass or whatever it happens to be that forms dew. So here's our challenge. How can we get moisture out of the atmosphere? I know it's humid in here, but I don't know how I can get that moisture out of the atmosphere. What factors can I change? Can I change the humidity? Well, maybe if I took a shower and the room got all steamy, I could change the humidity, but that wouldn't help me get the moisture out of the atmosphere. What factor can I change that would make the moisture come out of the atmosphere? We're going to change the temperature. So what we're going to do, we need a glass jar, and I'm going to put some water in it. So I've got some water. Now I'm going to put some ice in it. Now I'm putting the cap on it and tighten it because I don't want any of the water that's inside to demonstrate what I'm doing. So I'm keeping this safe, that it's sealed in there. What's happening is the water inside is chilling the outside of the glass. That's what I'm going for. And you notice that there's nothing on the outside of the glass. It is not wet with condensation. We're looking for condensation. We're looking for something to be pulled out of the atmosphere. So I'm going to set this outside right now because right now it's pretty humid outside. And we'll come back and check on it in a little bit. Right now the weather conditions outside is about 74 degrees. The dew point is 61, which means that 74 is hotter than the dew point. So it's not going to form dew naturally. And then the relative humidity is 64. 64 is the percentage of how much water moisture, how much water vapor there is in the atmosphere that the atmosphere could potentially hold at that temperature. And we know that based on the temperature, the warmer it is, the more moisture it will hold. Once it gets to 100%, then you start seeing clouds form. 100% humidity means that you start seeing the water droplets. You could see water vapor in the atmosphere in the form of droplets that are condensing into clouds or they're condensing into fog. That's what happens when you hit 100% relative humidity. All right, to wrap up some of our concepts today. How is the air's capacity to hold water vapor influenced by air temperature? How is the air's ability to hold water vapor influenced by air temperature? As air temperature increases, the capacity to hold water increases also.